The linearity property of infinite series is interested in looking at what happens if I multiply a constant times my series. Will that affect the convergence? And what about if I have a sub n plus or minus b sub n as a series? So in other words, I have a series that has two terms with n being added and subtracted. Is there something different going on with the convergence there? So this linearity property is something that shows up in a number of fields in mathematics, and you'll probably see this again if you take a linear algebra course, this linearity property. To use this with the infinite series, we have a couple of conditions here. So the first condition is that the series of a sub n needs to converge, and the series of b sub n needs to converge all on their own. And then we're given that k is a constant. So given this, if all of this holds true, then the series of a sub n plus or minus b sub n is going to converge to whatever the series of a sub n converges to, plus or minus whatever the series of b sub n converges to. So we can just add or subtract those two independently. And then if I have the series of k times b sub n, that k is a constant that I can pull out in front. So that is going to work just the same as it does with limits, derivatives, integrals. So this is going to converge to k times the series, whatever the series of b sub n converges to. So you can just multiply that together. All right, so let's look at an example. I have this series n equals 0 to infinity of 2 plus 3 to the n over 4 to the n. What I'm going to do is I'm going to split this into two series or two fractions. And so I get that 2 is a constant I can pull out in front. I have this series of n equals 0 to infinity of 1/4 to the n plus the series n equals 0 to infinity of 3/4 to the n. So look at this one first. This is a geometric series because I have a number raised to the n. The absolute value of r is equal to 1/4, which is less than 1. So I have convergence. And this second piece is also a geometric series. That's 3/4, a number raised to the n. And my r, the absolute value of r is 3/4, which is less than 1. So that also means it converges. That means this property up here is going to converge by linearity. I'm sorry, that series, I think I said property. That series is going to converge by linearity. And we can actually figure out what it converges to. So let's put a 2 here. This one here, these are infinite series, so it'll converge to first term over 1 minus r. My first term is a 2 here, since if I plug in a 0, this is 1. So I get 2 over 1 minus a 4th, plus the first term here, when I plug 0 in, is a 1. So I get 1 over 1 minus, and my r is 3/4. So that's what this will converge to. And then I have a little bit of a wacky example here. So I have the series n equals 1 to infinity of 0. Adding up a bunch of zeros, that's going to be equal to 0. Nothing wrong there. And now I'm going to employ one of mathematicians' favorite tricks. Mathematicians have two tricks. We like to add clever forms of 0 or multiply by clever forms of 1. In this case, I'm going to use a clever form of 0. I'm going to rewrite 0 as 1 minus 1. That's true. So I will rewrite this series as the series of n equals 1 to infinity of 1 minus 1. And I will rewrite it again as n equals 1 to infinity of 1 plus the series n equals 1 to infinity of negative 1. And then one last rewrite. Since that's a 1 there, I can rewrite this series of 1 as a 1 to the n. No matter what n is, when I plug that in, I'm still going to get a 1. So these two are the same, or they're equivalent, I guess I should say. And now if I look at this, I have a number raised to the n. I have a number raised to the n, I have a geometric series. And in that case, my r is equal to 1, which is greater than or equal to 1, and it diverges. But that converged, right? So what am I trying to show you here? What I'm trying to show you is that this property doesn't work in reverse. You can't take a series that converges, split it into two pieces, and then claim each piece on its own converges. This property doesn't work that way. It only goes one direction. You have to know the pieces on their own converge, and then you can apply that to find the convergence of them being added or subtracted.